All right, let me review.
And we're live.
Topic. All right, we're back on. We're going to review one topic from the past because it's going to come up in our discussion, and that is, does anyone recall this word? Resistant. Do you recall hearing it as a word?
Yeah.
Okay. Well, a resistant, I'll write out the definition so you can remind yourself. I'll leave a blank so it'll all come rushing back. Resistant is a statistic unaffected by something. A statistic unaffected by something. Do anyone remember what a resistant statistic is? What would I put in the blanks? Anybody? I'll give you the second blank.
Say outlier.
I could put it in the word values there as well.
Standard measures.
Standard measures.
Outlier.
Yeah, you've got the idea. Extreme.
Extreme. I'm writing X and
All right.
extreme.
So, for example, suppose we took a test and you got a 2%, an 8%, and an 11% on the test. All right. If you add those up and divide by 3, you would have the mean. So the mean of those three numbers is, come on, you can do this, 7.
Your greater memory will be
All right,
7%.
what is the median? Do you
Bunch
recall?
of angry emails.
The median is the middle number, and when they're in order, which they are, is 8. So now let's go and throw in a big number. Say a fourth person was absent, and then they took the test, and we got a 33. All right, so what's the new mean? So we have to add those four numbers up and divide by 4. 44, 54 divided by 4 is
It's like 10.25.
Fully good.
54.
10 and a quarter.
13.5.
All right. All right, about what happens to the median between, it'll fall right in here between 8 and 11.
Miss Powell, it's 13.5.
Yeah.
Oh, 13.5, sorry.
That's what I said.
Oh, sorry.
Because I took 30.
All right, I thought I heard someone. So the median has changed between 8 and 11, was halfway. 9 and a half, no, 8, 9, 10, 11, 8, 9, 10, 9 and a half. All right, so notice when we put in an extreme measure, a large value, the mean went from 7 to 13 and a half, but the median just changed a little bit. So we say that the mean is non-resistant. So the mean is non-resistant. So if you put in a large value, it's going to change the mean. The median is resistant. It doesn't change that much when you put in an outlier. What about standard deviation? Would I put that in the resistant or non-resistant camp? Ideas about standard deviation?
If you add numbers, it's
It's
going to change.
resistant.
Pardon?
No, it's going to change. If you add bigger numbers, it's going to change.
Because remember how we actually calculated standard deviation? We took the mean, we took the values and minus the mean and squared it
Oh, yeah.
and divided by, and we did all that for each of these, x2, so we went up to xn. We always minus the mean and we divided by
And
n minus 1. Thank you. So, and that I think was the variance. So then we took the square root. But the key is not remembering what standard deviation is, but notice inside of the calculation of standard deviation was the mean. And the mean is highly non-resistant, so standard deviation is also. Standard deviation and mean are non-resistant. Okay, that's going to pop up in our discussion, so I wanted to remind you what that means.
Okay, so wait, resistant means they don't change.
Resistant means they don't change.
Okay.
Right, they resist those outliers. All right, so I'll just leave that up, the the general definition I'll leave up. All right, so today we're going to learn about a new term altogether, and it came out of, if you would look back, remember that quiz that wasn't a quiz?
Yes.
Yeah.
All right,
Yes.
do you have it in front of you or nearby? Could you look at the quiz that wasn't a quiz? I'm interested on the one where we were putting on the device to change the gas mileage. Do you have that one? You, Andrew?
I don't think so.
You don't have a quiz that wasn't a quiz?
What, I'm confused for, oh, yeah, that
It's
take
quiz
some
on
homework
top.
things. Okay, yeah, I have that. Yeah, sorry, I didn't know what you were talking about.
Do you have it? Alright, notice, what was the sample size on that one? Can you peruse that? Brian, what was the sample size?
It was 15.
Alright, N was 15, so we couldn't assume normality when you're looking for our X bar. We had to have 30 or more. So I forced you to put it in your calculator and look at the data. The eyeballs come out and look at the data. And remember I said, that box whisker doesn't look normal. The histogram, it doesn't look normal. Wasn't that the day that we said, how do
Yes.
we, yeah, or it wasn't, it was another word.
Because you asked Shannon how to spell N.
Yeah. All right, so, and what was the third thing? The box width, the probability plot looked like that. And so, of course, we went like it was normal. But today, I'm going to tell you why, in more specific terms, why we took that low n equals 15 and looked at this data that was all and we still said normal is okay. We're going to go on with the confidence interval. I'm going to teach you why we can do that. All right. So, in certain cases, and they'll be like this one. To understand that, you need the new word. So, write this definition down. Procedures that are not strongly affected when a condition is violated are called procedures that are not strongly affected when a condition is violated is called, I remember some classes, they were just so upset with me that we accepted normal on that problem. They would like roll on the floor, they were so upset. They were not flexible like you. Caleb was not flexible as you, Dan.
Huh?
Caleb would get real upset when we would bend the rules a little bit. He was not very flexible.
Can you roll on the floor?
Practically. So, anyway, some classes, they had a hard time with bending the rules. So, when I'm talking about rules, this is the word condition. And what are the conditions that must pass to use a confidence interval? RIN. What are RIN again? R stands for what, Maggie?
Random.
And then I and N. All right, this is the one that this one deals with. We can bend the rules for N, not for R and I, but for N, if the procedures follow this word. If everyone got it down and ready for the word? It's a funny word. I always wanted to use this word. The word is robust.
Yeah, Romundus.
Raymond.
Robust. I always wanted to use that word, but this wasn't exactly the scenario. Procedures that are not strongly affected when a condition is violated is called robust. All right, so let's unpack robust. All right, so let's look at T procedures.
On babies. Use special.
When I say T procedures, that just means the confidence is establishing a confidence interval with a T star in it. That's a T procedures. T procedures are not robust against two things. Two things really mess up T procedures. and that is strong skewness and outliers. So, if we had taken that data for the gasoline mileage device and looked at it, and we had seen strong skewness, or we had seen outliers, we would definitely not be able to use normality or assume normality. So in that, if you go back and look at the data on that example, there was not strong skewness. It didn't look like a normal curve, but it didn't look like a skewed curve either. So if there was no strong skewness and there were no outliers. If you looked at the box whisker, it didn't have the little stars that were outliers. So it did pass in this regard. So T procedures are not robust against strong skewness and outliers, but if there is no strong skewness and no outliers, then they are robust. And you can use them when you don't see normal. So why is that? Well, we'll talk a little bit about why. So this is what's going on in your thought cloud. T procedures are not robust because here's how you get a T value.
Wait, they're never robust?
Oh, they're not robust when you have this and this.
So they are robust?
They are robust if there is not this and this.
Okay.
So we'll write that out a little clearer in a minute. X bar plus or minus T star, standard deviation divided by the square root of n. So why do you think that a T procedure is not robust against strong skewness and outliers?
Because it has standard deviation.
Yeah, why, and what is that?
Standard deviation is affected by, it's non-resistant.
Right, so, it's, very good, that's what I wanted you to say. This standard deviation is, we learned earlier, or relearned, that it is not resistant against outliers. So if outliers affect standard deviation, and standard deviation affects the T procedure, then we cannot use the T procedure when there are outliers, and that's why. But now let's boil it all down then. There's 3 rules. Number 1, rule number 1, when n is greater, so we're talking about T procedures. So if I'm in T land, what am I looking for? What's the parameter I'm looking for? Right, when I'm in T, doing a T procedure, am I looking for p hat? Am I looking for p or mu?
You're looking for mu.
You're looking for mu. So when n is greater than or equal, here's the 3. I don't think I will fit them on here. All right, I'll try. When n is greater than or equal to 30, do I say T procedures will work well or will not work well?
It will work.
Why?
Because if it's 30, then you're going to have a normal.
Right. We already learned that the sample is close to normal when n is greater than or equal to 30. So in case 1, when when n is greater than or equal to 30, T procedures work well. What was that theorem called? Do you remember? Here's its initials. Central limit theorem. That's the one that told us that, well, it said for large values of n, the sample would be normal. And we came up with 30 by experimenting. All right, number 2. All right, now, when n is between 15 and 30. All right, now I'm looking at smaller n's, below 30, so 29 on down to 15. T procedures are okay when?
Could it be less than or equal to?
No, because 30 is in this group,
Well,
and
15.
15 will be in another
Okay.
group. So between 15 and 30, T procedures are okay to use unless there is or I guess you would say there are strong skewness or outliers. Ryan, what was that again on that one we did with the gas device? Was it you who told me?
Yeah, what part of it was
Just what number N was?
15.
15. So it's not quite in this group, but it did allow us to use T procedures because when we looked at all that data, there was not strong skewness or outliers. It didn't look normal, and that's why I went but there was no strong skewness or outliers. So if you have that, you can skip the normal shape. If there's no strong skewness or outliers and it's between 15 and 30, go with T procedures. They work, they're robust, unless there's strong skewness and outliers. All right, so number 3, the last one was N, when the sample size is really small, when N is less than 15, let's still say less than or equal to 15. We're going to use T procedures only. I'll let you catch up. Only when the data looks normal. So you're going to have to look at the data. You have to look at it for part 2 as well. But when you look at it, when the N is small, 15 or lower, and it looks normal. What do I mean by looks normal? All I mean is, I'm a little slack on that. It doesn't have to look exactly like that, but it has to be symmetrical. It has to be symmetrical, unimodal. No outliers. So it has to be at least that close to normal in the eye. But do not use if you see strong skewness or outliers again. But if we, when the one Ryan and I have been discussing with N equals 18, we would, if that had been N equals 14, that graph was not near, that was not unimodal or symmetric. We would not have been able to use T procedures if N was 15 or lower, but it was 18. All right, so those are the 3 groups. Let's practice some of these by opening our books and looking at these 5 problems right now. You can actually do them right on this day 5. And it's our classwork. So we're going to practice these by looking at these 5 and seeing when we can use T procedures and when we can't. So open your book to number 66. That's on chapter 8.
Okay, so we do this on the notes
Yeah.
page.
You can do it right on that day 5 page.
Do we know what page it's on?
Well, it's kind of just find chapter 8 and keep going until you find it.
Is this the kind of thing where if we don't finish, the ones left become homework, or
Yeah,
is
we'll finish.
homework
I
something
think
different?
We'll finish. We have
Okay.
other homework, so this is classwork.
Okay.
All right.
Page 5.
All right. Read the first one to yourself silently. Number 66. You need a book, Ryan?
Yeah, I have a book. I can get it out.
All right, that would help. All right, this one I don't think this one talks about robustness. The first one does it.
No.
All right.
What critical value T star?
Yeah, it's just practicing looking up a T star number. So I threw that one in to get us all loosened up. All right.
Oh, I don't have to do it.
All right, I want you to look it up on the chart and also on your calculator so you remember how to do both.
I do not remember
I don't know.
See, is it second bars, inverse T? I forget myself. Second bars, inverse T. Is there an inverse T under
Yeah.
second bars? Okay. All right. Are they still videotaping?
Yes.
All right. Can they see the assignment?
Yes.
All right. Why don't you shine a light on those 5 problems on your book? and
Yeah, I
just-
showed them 66 just
Okay.
now.
All right.
I'll show them the rest.
All right. Show them the rest, and we'll turn that off for now.
Is
A while.
area
Got it.
77?
Yeah.
Did
60.
inverse T come up after second bars?
Pause if you need to. I'm gonna go to the
So
next
wait,
one.
inverse bar, wait, what was it? Inverse what?
Inverse T.
And then-
All right. Video land. We're going to work on these, and we'll give you the answers when we're all done. One more.
Set 3 more.
Okay. He's going to show you the rest, and then we'll shut off the
71.
video for a while. Uh-huh.
For this one.
And then, hold on.
This one's basically,
You need 76, right, not 77.
That's the rest of 71.
because isn't that when you have to do the minus one of what that gives you?
Wait, so what do you do when the number
Oh,
is
yeah.
too big?
Yeah, that's the sample size. So the degrees of
biggest
theory
number.
is 76.
So,
You just-
All right.
I got different numbers when I use technology in this. But I think it's because I don't know how to do it on my calculator.
All right, I believe he
And
goes second bar.
78.
Because you have to do one minus, because it's such a really.
Second bars.
All right.
And then
Bye
we
bye.
go inverse T.